Hello students, I hope you all are fine. Students, today we will do bond parameters. This is also topic of unit 4 chemical bonding class plus 1. Bond parameters. Students, what do you mean by the bond parameters? Actually students, in case of covalent bond, we can determine the strength of the covalent bond by knowing the values of some parameters like bond length, like bond order, bond energy, bond strength, okay, bond angle. All these are known as the bond parameter. So one by one we will discuss all the bond parameter. First of all, we will discuss about the bond length. Bond length. What do you mean by the bond length, students? Bond length is defined as the closest internuclear distance. Closest internuclear distance between the nuclei of two bonded atoms. What do you mean by this, students? Let us consider if I have one molecule, this one is one element I am having. Let us consider it is a, it is a, okay students. And if I have second, this one let us consider it is b. Then students, what will be the internuclear distance between them? Here let us consider this one is the center of this, and this one is the center of this. Okay students, so here students, let us consider I am talking about H2. I am talking about H2, hydrogen gas. So what will happen here, students? One electron it is having, and this hydrogen, this one also having one electron. Then student, by mutual sharing, each one will share one electron and they can form covalent bond between them. Then students, what will be the length of this bond? That is known as the bond length. That is known as the bond length. So how can we calculate the bond length, students? Here let us consider this one is one hydrogen and this one is the one. So here we will discuss about the internuclear distance. Let us consider this one. This point is nucleus. This point one is the nucleus. Okay. And student, this one is nucleus of this one. Then students, what is the internuclear distance? Let us consider this one is the radius for this one, R1, and this is also R2. Here we can take R1 also because both are the hydrogen atom. So I can take R1 also, students. Here also I can take R1. Okay. So what will be the bond length, students? Here bond length will be R1 plus this R1 means 2R1. This one will be the bond length here. This one will be the bond length. And students, let us consider these two elements are the different. This one is hydrogen. Consider this one is the chlorine. This one is the chlorine. Then further we can say the internuclear distance between them. Let us consider this one. This one is the nucleus of the hydrogen. You know where in an atom, one nucleus is present there in center. Okay. So student, this one is nucleus of hydrogen, and consider this one. This one is the nucleus of the chlorine. So internuclear distance between them. Internuclear distance between them. Let us consider radius of this. Atomic radius of hydrogen is R1 and atomic radius of this chlorine, this one is R2. This one is R2. So students, this total is known as the bond length. The internuclear distance between two isolated elements is known as the bond length. So student, here bond length will be R1 plus R2. R1 plus R2. I hope this concept is clear to you. Okay, so students, the bond length between the specific elements will be the particular, it will be the specific. Okay, for example, students, if I talk about the bond length between carbon and carbon element, carbon and carbon, if there is single bond between carbon and carbon, if there is single bond, then students, if there is single bond between carbon and carbon, then here this bond length is 154 picometer. And if there is carbon to carbon double bond, carbon to carbon double bond, then this one bond length is the 134 picometer. And if carbon to carbon triple bond is there, carbon to carbon triple bond, then this bond length is 120 picometer. Okay, students. So bond length is specific for specific element. So what do you mean by the bond length? Student, bond length is the closest internuclear distance between two nuclei of two bonded atoms. Here two bonded atoms, this one A, this one B. These are the two bonded atoms, and the internuclear distance between them is known as the bond length. In a molecule, bond length are measured by the spectroscopic techniques. So bond length is measured by the spectroscopic techniques. Spectroscopic techniques like X-ray diffraction, like electron diffraction technique. Okay, we can calculate. This one is the experimental data, students. Okay, experimentally we can tell about the bond length between two bonded atoms. Okay, students, I hope this concept is clear to you. So first one bond parameter is the bond length. Bond length is the closest internuclear distance between nuclei of two bonded atom. Then students, next one bond parameter is bond energy. Bond energy means the amount of energy. This one is the amount of energy required to break 1 mole of a particular type of bond. Between two atoms in gaseous state is called the bond energy. Means student, how much amount of energy is required for breaking 1 mole of the substance? For breaking 1 mole of the substance, how much amount of energy is required? That one is known as the bond enthalpy. Okay, students, like students, if I talk about further hydrogen, so there is the internuclear distance between them. Okay, that is known as the bond length. Then students, how much amount of energy, then they are forming a bond. So how much amount of energy required for breaking this bond is known as the bond energy. Energy required, हमें इस बॉन्ड को तोड़ना है, ब्रेक करना है. एक मोल को तोड़ने के लिए कितनी अमाउंट ऑफ एनर्जी रिक्वायर होगी, कितनी एनर्जी हमें प्रोवाइड करनी होगी, कितनी एनर्जी हमें देनी होगी मॉलिक्यूल को, बॉन्ड को ब्रेक करने के लिए. दैट वन इज नोन एज द बॉन्ड एनर्जी. नोन एज द बॉन्ड एनर्जी. स्टूडेंट्स, बॉन्ड एनर्जी हमारी डिपेंड करती है जितना बॉन्ड लेंथ कम होगी. बॉन्ड लेंथ जितनी कम होगी, बॉन्ड लेंथ कम होने का मतलब क्या है कि अट्रैक्शन ज्यादा है, फोर्स ऑफ अट्रैक्शन ज्यादा है, तो उतनी ही बॉन्ड एनर्जी उसकी क्या होगी, ज्यादा होगी. उसको तोड़ने के लिए हमें ज्यादा एनर्जी प्रोवाइड करनी पड़ेगी. सो वी कैन से स्टूडेंट्स, बॉन्ड लेंथ एंड बॉन्ड एनर्जी, these are the inversely proportional to each other. Okay, if bond length is more, then we need to provide less amount of energy to break that bond. Okay, so students, bond energy is that amount of energy which is required to break 1 mole of the substance, and SI unit for measuring the bond energy is kilojoule per mole. You know very well, kilojoule per mole. It is the unit of the energy. Okay. So here we are talking about the bond energy. Okay. So obviously it is also an energy. So its unit will be also kilojoule per mole. I hope this is clear to you. Then students, our third one parameter is bond order. Bond order. The number of the bonds between the two atoms in a molecule is called the bond order. Means how many bonds are formed between two elements. Okay, that is known as the bond order. For example, students, if I talk about hydrogen, you know very well, if I talk about hydrogen, H2, hydrogen gas, then student, you know very well, there is one electron in outermost shell of one hydrogen. Okay, then students, by sharing one electron, they can complete their octet, they can complete their not octet, duplet, they can complete their duplet. Then students, here they need to share only one electron, means they are forming single bond only. So its bond order is 1. But student, if I talk about oxygen O2, what will happen here? Oxygen. You know very well, oxygen has 6 electron in its outermost shell. There are 6 valence electron in case of the oxygen. Because oxygen atomic number is 8 and configuration will be 2, 6. So there are 6 valence electron in one oxygen element, and in second element of oxygen also there are 6. Then students, this one oxygen, it need 2 more electron for completing its octet, and this one also needs 2 more electron for completing its octet. Then student, they can do mutual sharing. They can do mutual sharing. Then what will happen? 2 electrons are shared by this one and 2 electrons are shared by this one. Okay students, after sharing, it has 6 plus 2, 8. This one also 6 plus 2, 8. So both are completing their octet now. Then students, they are doing sharing of 2 electrons. Means they are forming one bond and one. They are forming total 2 bonds. So students, here bond order is 2. Bond order is 2. Means how many bonds are formed between 2 elements, that is known as the bond order. That is known as the bond order. Now, you can take one more example students. If I talk about N2, nitrogen gas. So student, here 2 nitrogen, so here 2 nitrogen, one is this one is this one. You know very well about the atomic number. Atomic number of nitrogen is 7. Okay, so its configuration will be 2, 5. Means there are 5 valence electrons. Okay students, then you will draw the Lewis structure 3 and 2, 5 in one nitrogen, and student here also in second one also 5 valence electrons. Now students, this one nitrogen has 5 electron. It needs 3 more electron for getting stability, for completing its octet. And this one also needs 3 more electrons. Okay students, so means they can do mutual sharing and each one will share 3 electrons. Okay, then students, what will happen here? Here 3 electrons will be shared by each one. Okay, then students, they can form 1, 2, 3, means 3 bonds between them. So here bond order, here what will be the bond order? Here bond order will be 3. Bond order will be 3. Then students, what is the bond order? Bond order, the number of bonds between 2 atoms. So here between 2 atoms, only one bond So bond order is 1. In case of O2, there are 2 bonds, so bond order is 2 here. And in case of N2, here number of bonds are 3. So bond order is also 3. Okay. Then students, there is a simple trick also for finding the bond orders. Okay, we will learn how to calculate bond order with respect to molecular orbital theory also. So students, we will discuss in this unit molecular orbital theory. But now, how can we calculate bond order by using a simple trick? We will see that one. Then students, if you know about the number of electrons, okay, then students, if number of electrons you know and you know about then you can calculate bond order by using simple trick only. This is a trick. How can we calculate? If number of electron 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. Okay. Then students, here if electrons are 9, then bond order will be 0. If electrons are 10, then bond order will be 1. Okay. Then up to 3, you will increase by half. You will increase by 0.5. Okay. 1.5 to 2.5, 3. After reaching at 3, you will start to decrease by half. Then 2.5 to 1.5, 1, 0.5, 0. Clear students? Then you can see I told you that in N2 there are 3, in O2 there are 2 and in hydrogen there is 1. Then students, you can see by using this trick only. If I talk about O2, you know very well, one oxygen has atomic numbers 8. Okay, so here number of electrons are also 8. Okay, so students, here total number of electrons are there are 2 oxygen atoms. So in 1 there are 8 and in 2 there will be 16 electrons. And if electrons are 16, then bond order will be 2. So its bond order is 2. Okay students, in case of nitrogen you can see also nitrogen. So here one nitrogen has electron 7. There are 2. So 7 plus 7, 14. Total 14 electrons. And if electrons are 14, then bond order will be 3. So by using this simple trick also, you can tell about the bond order. Students, from here I can say that isoelectronic species has same bond order. Means students, I am telling about this trick for number of electrons. Isoelectronic species means the species in which same number of electrons are present. The species in which same number of electrons are present. Like students, if I talk about N2, nitrogen and Cn negative. Here you can see, in case of nitrogen, you have already seen there are total, one nitrogen has electron 7, second one also 7, so there are 14 electrons. If there are 14 electrons, then its bond order will be 3. Its bond order will be 3. But if I talk about cyanide ion, so student, here carbon atomic number is 6, so number of electrons are also 6. 6 plus nitrogen 7, one negative charge is here. One negative charge is showing that it is absorbing, means it is gaining one more electron. Okay students, so one more electron is here. This negative charge is showing. So student, here 6 plus 7, 13 plus 1, 14 electron. So in both N2 and Cn negative cyanide ion, electrons are same, means bond order will be also same. So its bond order will be also 3. Okay students, so in this way, if number of electrons are same in 4 more species, then their bond order will also be the same, means isoelectronic species have the same bond order. So student, this simple trick you can use for finding the bond order. Okay, I hope this is clear to you. First of all, for 9 electron you will take 0. For 10 you will take 1. After that you will start increase by half. Up to 3 you will do this one. After reaching at 3 you will start to decrease by half. You will start to decrease by half. And by using this simple trick you can calculate the bond order. Okay students, I hope this concept is clear to you. Then students, our next bond parameter is bond angle. Our next bond parameter is bond angle. What is the bond angle? It is defined as the angle between the orbitals that contain bonding electrons pair around the central atom in a molecule. Students, for example, if I talk about water, so here we will see the central atom. Here central atom is oxygen. Okay students, so the angle between the central element and the surrounded elements, formation of an angle take place, and that angle is known as the bond angle. That angle is known as the bond angle. Okay students, in oxygen there are total 6 valence electrons, so it is forming 2 bonds and 2 non-bonded electrons are here. So students, there will be the bond between the central atom and surrounded atom, and this one is known as the bond angle. There are some factors also which affect the bond angle, so we will discuss about that also. Okay students, so here bond angle is around 104.5 degree. Okay students, so bond angle is the angle between central atom and the surrounded elements. It is expressed in degree. It is expressed in degree, like it is 104.5 degree. That can be experimentally determined by the spectroscopic techniques. Students, it is also an experimental data, so it can be determined by the spectroscopic techniques. It gives some idea regarding the orientation of orbitals around the central atom in molecule. Hence, it can be used in determining the shape of molecule. Okay, by knowing the angle, we can have an idea about orientation of orbital, and students, about shape of the molecules. For example, students, if I have CO2, if I have BeF2, okay, so here angle is 180. So I can tell shape by knowing the formula only. Okay, by knowing the angle only, means it is linear. Because it has angle of 180. Means here elements are existing in a straight line. Okay, so their structure, their sorry, not structure, their shape will be linear. Okay, students, here means angle between oxygen and hydrogens. Here bond angle is 104.5, means they are showing some bent structure. They are showing some bent structure. They are not linear, because if they are linear, so there should be angle 180 degree. So student, by knowing the angle, we can have an idea about the shape of the molecules also. So what is the bond angle? The angle between the central atom and the surrounding atoms. Okay. So this one is the bond angles. So today we have discussed about the some bond parameters. What are they? We will discuss also what factors affect them. What are the factors which affect them? Okay, students. So one by one we will discuss. Factor affects bond angle. Factor affect bond angle. So which factors affect the bond angle? First one factor is the hybridization. First one factor is the hybridization. Students, we have not discussed about the hybridization till now. This one is also a separate topic in our unit. So we will discuss about that also. But student, now we will know about some main points of hybridization also. You know, here as the percentage as character increases, bond angle increases. What do you mean by this? Students, there are type of hybridization. I will explain this topic separately. So here you will understand only this thing. There are the hybridization like sp2, like sp3. Okay, students. So here you can see sp. If I consider total 100 if I consider, then here 1s and 1p both are in equal part. Then I can say 50% of this one and 50% of this one. So here s character is also 50. Here s character is also 50. Here 50% s character. But student, if I consider here total 90, then what will be 33? They s and p are in 1/2 ratio na. So here 33.33 and 66.66 around, this will be the. So student, here s character, here s character is 33.33% approx, and here s and p are in ratio 1/4. So 25 and 75. So here is character is the 25%. Okay, students. So here you can see, if s character increases, then bond angle also increases. Bond angle also increases. So students, simply if I talk about the hybridization of sp, then here angle will be the 180 degree, and in sp2 this angle is 120, and in sp3 this angle is 109 degree 28 minutes. Okay, so you can see here s character is maximum, it is 50%. So its angle is also greatest. Here s character is 33.33, means less than this one. So angle is also less. Okay, and here s character is minimum. So this one is also smallest angle. So students, bond angle is directly proportional to the s character. S character. Okay, this one is the one factor. Our second factor is number of lone pairs on central atom. If number of lone pairs increases, then bond angle decreases. Bond angle decreases. For example, students, if I talk about CH4, if I talk about ammonia, if I talk about water, then students, here carbon has outermost electrons, it has 4 valence electron. So students, No lone pair is here. Here lone pairs 0. So here bond angle is 109 degree 28 minutes. In case of ammonia, one lone pair is here. All thing we will discuss in case of hybridization. You know very well there are 5 valence electron in ammonia. So but it is forming only 3 bonds. Okay. So one pair is non-bonded. It is known as the lone pair. Means here lone pairs are here lone pair 1. Then students here angle. This is not one here. Geometry is same but angle different. Here angle will be the 107 degree only. But in case of water, if I discuss oxygen has 6 valence electron. It is forming 2 bonds. So 2 non-bonded electrons are here. 2 pair of non-bonded electron mean 2 lone pairs. 2 lone pairs are here. Okay, students, 2 lone pairs are here. Here geometry is also same, but student angle is further decreasing. It is around 104.5 degree. So you can see if number of lone pairs are increases, then bond angle is decreases. So we can say bond angle is inversely proportional to the number of lone pairs. Okay, students, I hope this one point is also clear to you. Students, some more points are there. We will discuss these tomorrow. Okay, so I hope all points are clear to you. So thank you. Have a nice day.